Hi, I'm Kevin Keller, the pragmatic statistician. In this episode of Street Stats, we're going to talk about the impact of time ordered data on our graphs and statistical analyses. This topic came in from a viewer, and I thought, wow, I should have made that my very first episode. This topic is so important. So here we are, let's talk about it. When you went through your statistics classes, most everybody learned statistics in the same basic order. You learned about the difference between descriptive statistics versus predictive statistics or inferential statistics. Descriptive statistics are facts. How much rainfall was there in the past month? How many points did LeBron James score on average? And so on. And then you got the bad news that this class was not going to worry about descriptive statistics. We care about predictive statistics or inferential statistics. These are based upon a sample from a population. Based upon that sample, we are going to predict what will happen in the future. Now, there is a formal underlying assumption that was given to you once during your class, but then was never mentioned again. And likely you were answering emails when that assumption was given. I know what it's like. All of the statistical methods you learned about in class rely on the data being independent and identically distributed. You know why you didn't remember that? It's because your instructors didn't say it exactly that way, because that sounds incredibly dense and confusing. Or if they did say it that way, they made a soft sell and then they moved on quickly. So let's break that down. Identically distributed is far easier. Let's imagine you make a product or service in offices in New York, Miami, and Los Angeles. In theory, that product or service should all be identical. But if you go, yeah, but there's differences in whatever way, then they are not identically distributed. You can't combine the data. But you probably already knew that. You keep the data streams separate because there's some reason why they are different. That's identically distributed. And within a facility, you might make the same product, but on different lines. There's something different about those lines. Or maybe a hospital, there's a main hospital in a city, and then there's a bunch of branches from that main hospital. And that main hospital has the very best of the doctors and nurses on staff. The others are certainly competent, but the numbers of performance are different. And so you understand that. And there's countless reasons why data is not identically distributed. And you understand that. You separate out the data, good for you, absolutely the right move. But the much harder one, and the one we typically ignore, is the idea or concept of independently distributed. This means as you gather a data point, the next data point should be completely unrelated. You have absolutely no clue as to what value you're going to see, other than it's going to fall within a certain range. How do we test for that? We do an SPC chart, or at very least a trend chart. And here's a good way to test how good your training materials were. After they told you that we weren't going to learn about descriptive statistics, we were going to learn about inferential statistics, was the very next thing you were taught is to plot the data over time. And if so, then probably they did a great job. But if you learned about summary statistics, you learned about graphical methods that didn't start with the trend chart or the SPC chart, then we need a reboot. So here's our reboot. When you get or collect data, after you've done your data management activities, cleaning it up for analysis, testing for outliers, wrong data values, fat fingers, all that sort of thing, the very first thing you do is you plot your data over time. The only exception is if you went out to the line and grabbed a whole set of data at once, or it's just a snapshot in time, then you wouldn't plot your data over time. Don't calculate the average. Don't plot a histogram. Don't do any of that before you test your data over time. So we're going to do a very simple example. We're going to look at two sets of data. All we care about is obtaining summary statistics and simple graphs. So I'm going to go to EngineRoom, and I've got a data set here. It's called time series problem. And the two columns are constant mean and trending. Uh, and this data, if you look at all 100 data points, are ultimately identical. It's all the same data values, but they're organized a little differently. So we're going to close that off. And in EngineRoom, I'm going to go straight to graphical summary because within that, I can get a trend chart. So I'm going to go to my problem or my data set and drag in constant mean. And one option that EngineRoom asked me is the data time ordered? And I'm going to say yes. And I'm going to click continue. And the last button on here is trend chart. And the only reason it's last is it's optional if we had a snapshot in time or data ordered. So when you went through your SPC training, you were asked a question about, is my data in control? And that's a great question if we're trying to assess the performance period after period after period. But in this case, all that we care about is my average stationary? Is my average essentially the same across time? And we can kind of look at this and eyeball and say, it appears to be. But we could also statistically verify that if we go up to quality tools, control charts, whoops, control charts, X moving range chart. I moved my mouse too quickly. I could put that value over here and we can get a control chart real quick. And we can look, plots that average over time, and it doesn't look like we have any trends or shifts. We've got a couple of points on the moving range chart that pops out, but overall, is my average stationary over time? The answer is yes. So we verified that. Now, why does it matter? Because now all of these statistics over on the left-hand side are valid. All of my graphs here, my histogram, my box plot, my confidence interval plots, all of these I can use in assessment of my process, whatever that data might represent. All right. But the purpose of this presentation is what if that's not the case? So this is exactly the same set of data, but it's organized just slightly differently. And I click on the trend chart, and what I see is a trend over time. It's going from lower values up to upper values. And again, I could do an SPC chart, but the point of this graph is to assess, is my mean stationary over time? And if an SPC chart might be a better approach to do that, I can, certainly. And I would never discourage people to do an SPC chart for sure. And so you can see that we had our values are mainly below the average at the beginning, then it's close to the average, and then it's above that average line. So it appears that over time, the data is trending slowly upwards. Now, that may be a good thing or a bad thing, depending upon your process, but that's where we are. Now, here's the skinny. All of those statistics on the left-hand side are completely invalid. Now you said, well, wait a minute, Kevin. Earlier, we talked about the fact that we could measure rainfall, we could measure how many points LeBron James had. We could do all those things. Those are descriptive statistics. It's what happened in the past. But you're in business and your vice presidents, your directors are asking you what's going to happen tomorrow based on what has happened today. And if I say, Mr. Vice President, our average was 3.43. It might be a little hard to see on your screen, but the average of this day is 3.43. And you showed this trend chart to the vice president. The vice president's going to go, well, wait a minute, I should see values around 4.5 in the future, not 3.4. All of these statistics are invalid. This histogram is invalid because when you show this, the underlying distribution is that my mean is stationary, that the points are identically and independently distributed from each other, and you have violated the concept of independence. Therefore, this graph is invalid. All of these statistics are invalid. And to go even further, if we look at all these hypothesis tests, if we have data that's drifting over time, all of your parametric tests, all of your non-parametric tests, all of them are invalid. Now, that's a pretty heavy reboot, right? So, what do? We don't pass go. We do not collect $200. We have got to change our mindset, but all is not lost. Does this process naturally behave this way? If it does, then there's a whole other world of statistics called time series analysis. Likely, your data follows either what's called a moving average process or an autocorrelated process. And it's more likely the latter, autocorrelation. Very fancy term, but it's higher level statistics. So if you have data like that, you probably need to seek out somebody within your company that has more background in time series data. All right. But if your mean is stationary over time, all systems go. So be careful out there. The streets are messy and so is data. But remember, there's always a way.